to the exam study. So I'm going to go over the exam review sheet. I won't be covering the whole sheet in its entirety, but I will be going over a healthy number of things here. Some of it, yeah, so we'll be going over the majority of the review sheet for the exam so that you can be hopefully prepared for the exam and do well on it, which is the main goal here, right? So like I said, I won't be doing everything, but I'm going to start. If you want to have your exam sheet out while you go over this, maybe take some notes if you want. That's up to you entirely, obviously. Of course, you can always pause it and go over things. Pause the video, that is. But anywho, so I'm going to go and go over this. We'll start with the number 1B for loops. And the problem asks us to skip over sequences or sequences of numbers. For example, displaying 1 to 100, including 100, but don't displaying 20 to 30, not including 30. Or at least that's how I interpret this to mean, if you will. And so, yes, I'm going to show you how to do this. And that's probably the main. I'll also go over for the loops. I'll go over the letter loops because that one was asked specifically. So we'll go over that one as well. And that should cover, for the most part, how you display these. It's pretty simple. I'll talk about the other ones. For instance, the first one, iterating backwards from a high number to a small number, it's just going to be counting down. It's probably the simplest way. So you would have your counter set to the high number and your condition set to the lower number, and have your counter do a minus, so it decrements as you go down. That's how you do that. For the let's see, using increment, so that's the that's interesting. That plus or minus 1. Other than plus, so that's just instead of saying a counter plus or counter minus, you say counter times equal or plus equal 2 or 3 or so on and so forth. So you just use that in place of the decrement and increment dealios. And the patterns, we'll go over the pattern one too. That one's can be challenging. Alright, so to get started, like I said, I'm going to start with the 1B, if you will. I already had this kind of written up here for us. And basically, first thing I did was I wrote, or I initialized, I should say, the counter, and said integer, initialize it to the value of 1. The reason being is because we're starting to count from 1. So since we're counting up, you kind of want to set your counter or whatever your variable is for this instance. You want to set it equal to your starting point, and our starting point is 1. So that's why I have it set to 1. And then for our while loop, I'm using a while loop obviously. So for a while loop, and our condition for our while loop is while counter is less than or equal 1, because I want to include the 100. Excuse me, less than or equal to 100, because I want to include the 100. So our counter is less than or equal to 100. So as long as that is true, we're going to continue the loop. As soon as it's strictly greater than 100, we're going to exit that loop, which is what we want. We don't want to continue displaying numbers past 100, so that's why it stops at 100. Inside, so basically each time you're going to want to have this console.write line counter, or I use the console.write because I want them all to be on the same line, plus a space to kind of give a separation there, obviously, so it's easier to read. So counter.write plus the space. So each time this while loop will loop, if you will, actually what we're going to do is we're going to do this. Okay, be that way. So we can have I just want to, you know what? We'll do this. There we are. Alright, so basically you write this, you want this to kind of display each and every number with a space. So that's the end goal, right? So if I were to run this as it's displayed. So it's not, we're skipping over the parts that I just commented out. So if I were to display that, or excuse me, run that, it runs forever because we don't have that update. So we're going to continue to display the number 1. As you see, it's going and going and going and going. You can watch this little guy go down and down and down because we're literally, like, there's so many ones. So I'm going to exit that because I don't want to do that forever. So I'll add in, or I'll uncomment, our update line of code. So you have our update here, which is exactly what you want to have, right? So I'll go ahead and run it with the update. So now we have this nice, neat count that goes from, or displaying of numbers that goes from 1 all the way to 100, which is exactly what we wanted, right? Well, not exactly, but we're getting there. But like I said, the end goal of this was to display every single number from 1 to 100, excluding the 20s, right? So excluding the 20, 21, 22, 23, 24, 25, 26, 27, and 28, 29. So every other number wants to be, we want that displayed. So in order to do that, we can uncomment this. We would write this bit of code here. So we have this bit of code, and it's an if statement. So if the counter is not, so basically this is saying counter is this condition, if you will, is counter greater than or equal to 20 and is counter less than 30, strictly less than 30. So this basically is the numbers 20 through 29 would be included in this condition. Those are the numbers I want to exclude, so I'm going to negate that. So basically saying every number with the exception of that range 20 to 29 we want to do this with, and we want to display that. So that's exactly what we're going to do. And I'm going to move this counter just for kind of show you the mistakes that would be made. Common mistakes that are made, I should say. I'm going to put my counter in my if statement. Now, I'm going to tell you right now, this will cause an issue. It will not cause an error per se, but it will cause an issue with our code. So it won't break the program. The program will still run, but it won't run properly. So, as you can see, well, I guess it would technically break it. We're in an infinite loop, and it stops at 19, and we just infinite loop of nothing, which is obviously not a good thing, correct? Because what happens here, this counter became 1. Oh, it does. So, bring that back up. Where'd you go? So counter is 1 to the first iteration. We go through, we update. This is true, so we update and go all the way up till we get to 20. So now counter has become 20, right? So we go 19, right? So counter is 19. We go through, we enter our if statement. This is true. We enter our if statement. We display 19 with the space, and then we update our counter by an increment of 1. So we update our counter by 1. Now our counter is equal to 20. Go back through this while loop, counter is equal to 20, then it is in fact less than or equal to 100. So we enter into our while loop. It does not meet this condition, so we skip it, and then we keep going in our while loops, and we're going to loop and loop and loop and loop and loop forever, quite literally, until we end the program. So force quit the program, if you will. So obviously that's not what you want to happen. You want to continue counting, you just don't want to show the count, if that makes sense. So I'm going to move my counter back down to here. So I move my counter back out of, so now the counter is in the while loop, but out of the if statement, which is where we want it. This should happen. So once I run that, now we've gone from, now we're stopping at 100 and exiting. That's great. So let's see. And as you can see, it jumps from 19 to 30. Now, to you, the use tool, to the user, this all happens automatically. There's no work that seems to be happening. What's actually taking place behind the scenes is this counter is just going through this loop. It's looping 20 through 29 times, through the 20 and 29, right? All the way to 20 and 29. So it loops all those times. The only difference is it's just skipping. It's skipping that deal. The bit of code in the if statement. So it's skipping over this line of code and going straight to the counter, increasing the counter until we get to 30. Until we get to 30, which makes this true because 30 does not, because this is 20 to 29. So once you hit 30, this is now true, and we enter back into this display and keep counting until we hit 100. Well, actually 101. Once we hit 101, we go up here, test it. 101 does not meet this, so we exit the while loop. And so that's the end of the program. Wham, bam, thank you, ma'am, we're done. And that is how you do the problem. We can make this a little more advanced, if you will, and which is what I want to do. So I'm going to make this a little more advanced, and what I'm going to do is I'm actually going to take this and I'm going to put it down here. I'm going to take this line, I'm going to completely remove it, and I'm going to put my counter plus plus over here. So I have my counter plus plus. So I actually have the update within this, and I'll show you what happens. Show you what I'm doing here. So I'm going to make this no longer a negation, but it's actually going to be the actual 20 to 29, and I'm going to hit the continue here. Yes. Continue. Yes. All right. To put in my continue, but before I put in my continue, I'm going to increase my counter by 1. So this is a little more advanced way of doing, a little bit fancier, if you will. And I'm then going to run it again, and again it works the exact same way, more or less. But what's happening here is we're going through. What happens is it goes through, and as long as the counter is not 20 or 20 to 29, as long as it doesn't fall into those, it skips the if statement, comes down to our console.write, and we display counter and add a space, and then once that's displayed, since this is a postscript, we're going to do that. That's the very last thing happening on that specific line. So remember, if you remember, there's postscript and prescript. So I could actually get really fancy and set this equals 0 and make this a prescript. Let's see if it ends up the same way. It does not, so there is an issue here, so we want to stop it before we get to 101. So then in that case, yes, there, now it works. So that's our prescript. So what's happening is it does this calculation first, so it increases the counter by 1 first, and then it runs the console.write. If you have a postscript, if you make it a postscript, it does the calculation last, and then it does, that's the very last thing that happens on the line. So in this case, it would do our console.write, displaying the counter, what it is, the current counter, and then adding a space, and then it would increase counter by 1. So go back to, I'm going to do that prescript. I kind of like the way that looked. So if I wanted to do it like that, that's fine. Now, when it's by itself, it really doesn't matter whether it's pre or postscript, because that's the only thing on that line. The only time that really comes into play is if you have other things going on that single line of code. Once you hit that semicolon, now we're on a new line of code and doesn't. So this is one line of code. Once I hit that semicolon, we're on a new line of code. You could even, if I wanted to be that guy, I could do this. This is a totally acceptable line of code. A lot of people wouldn't like that. There'd be a lot of people who have issues with that, but that is a legal, if you will, way of writing code. Like, it's still going to build, it's still going to compile and run. As you can see, the same way. It doesn't change it. Simply because C# does not care about white space, and since new lines are nothing but white space, it doesn't care about them. It doesn't need them. I'm going to keep it on a new line just because, personally, I like having that nice little neat appearance to my code. Alright, so that is the long and short on 1B. Moving on, I'm going to do creating a pattern, right? So I'll go and I'm going to write a delineated comment for us so that we can see what we want, or have a little more visualization of what we're trying to display. Alright, so in our delineated comment, we have, let's see, we have 1, 2, 3. One, 2, 3, 4, 5. 1, 2, 2, 3, and 1. Obviously, space there. So this is what we want to have displayed, right? This nice, neat, little, pretty diamond shape. There's a few ways you can do this. Probably the best way in my mind. If you want to get we're going to get fancy with it. We're going to get fancy with it. We want, so let's see. Yep, we're going to get fancy with it. So, I'm going to create a string called message, and I'm going to set it equal to an empty string. Now, I haven't really gone over how to do this one in a while, so so bear with me a little bit here. So we'll be using a while loop to go over this one. You could use a for loop if you wanted to, but I'm going to use a while loop. Just because I want to. And for start, I'm going to start it. Let's see. 1, 2, 3, 4, and 5, and it's 5, so 25. So I'll start with. So we're going to have a counter as well. That will be an integer. Let me comment this stuff out because we don't need this anymore. So our count is set equal to 1 for simplicity's sake. And then I have a while loop. While count is less than 25. So essentially, each iteration we're going to display something, whether that something is a blank space, or excuse me, just an empty space, or this asterisk or star, if you want to call it that, or a new line. Yes. And so I'm going to use a switch statement here. We haven't used a switch statement in a while. I haven't written a switch statement in a while. And I'm going to switch over count. Alright. In the case, let's see. 5, 10, 15, 20, and 25. So case 5. 10, excuse me, 15 works. In case 25. What I want to do is is actually different, so we'll make this is gonna you know what? No, we don't want that. So before this, or after it, yes, after it. After this, if count, yes. If count mod 5 equals 0. So basically, if it's a multiple of 5, then I want to add the message plus equal a new line. So basically, every time we're at a multiple of 5, I want to create a new line, which means this is going to be different. I'm going to get rid of that. So the cases that I want to display the asterisks is, let's see, 1, 2, and 3, 4, 5, and 6. Well, 4 and 5, yes. 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14, and 15. Alright. Excuse me. 16, 17, 18, and 19, 20, 21, 22, 23. Alright. So, put space here just for my mind. Yes. Alright, so in here, I'm going to write case 3, colon, case 7, colon, case 8, if you, and basically I'm going to write all these numbers you see up here, I'm going to write a case for each of those. Case 9, case 11, not 100, but 11. Scroll down a bit here. Case 12, 13, 14, 15, 17, 18, 19, yes, 19, 19, and 23, finally. So with each of those cases, we want to add to message plus equals an asterisk. Not an 8, but an asterisk. Or star, however you want to call it. And then we want to break out of our switch statement here. I can spell break right. There we go. Break. And then for our default, for the default case, what we're going to do is add to message a blank space. Like so. Space. There we go, boom. And then, of course, we have to break out the default. And so, essentially, for case 3, so we're going to... Oh, almost forgot the most important part. Count plus... plus. So, with each iteration of our while loop, we're going to increase our count by 1 at the very end. We're going through the switch statement. It hits the switch statement. It's going to take our count, and it's going to test to see if it falls under one of these keys. So if one count is 3, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 23, it will add a asterisk to our message, and then break out of that switch statement, and then test to see if count is a multiple of 5. If it is, it will display a new line. For our switch statement, anytime it does not fall under one of these cases, it will display a blank space. And then at the end, of course, increase counter. And then once we exit our while loop, I'm going to console.write line, and I just display the message. So this is a nice, neat way of doing this. There's many other ways we could have done if statements. We could have done a number of different things. I like this way because it's simple. It's very easy to read for anyone who's going through it and wants to figure out what's going on. Obviously, you need to know exactly how this works to understand it. But if anyone who knows who's reading code knows what understanding code is going to look through this and read this and understand what's happening. So, with that being said, we'll build it and run it. And it did not work. That's because I didn't put the wrong thing here. Okay, let's try that again. And there it is. Ta-da! And so that's how you would do that. Very kind of simple. It takes a little bit of... It's relatively simple, I should say, but it does take a bit of understanding how the code works and how it operates, and kind of ways to work around it. Obviously, it takes a little bit of thought process and some time, but once you figure it out, it's pretty simple, like many puzzles, if you will. So we'll move on to the next one. Let's see, the next one I'm going to do... or the sequence of letters. Now, the key about this one, sequence of letters A to Z and Z to A, the key about this one is remembering that letters and integers have a very direct relationship in C#. So if you remember, so if you ever forget where they're starting and where they're ending, also you can always do this. Right line. Our character, the single quotes. So, the ones you need to know. Or not necessarily need to know, or good to know, I should say. Or A. A is the best, certainly the one you need to know the most. That'll make things a lot easier for you in the long run. So yeah. And so I'm going to go ahead and copy that one. So the capital A is equal to 65, and the lowercase, or excuse me, the capital Z is equal to 90. Also, you can find out. So you just basically put the integer A, and then put in the character. So you can go from character to integer implicitly, meaning you don't need to use any kind of, you don't need to force it. Like it happens automatically. There's nothing else you have to do extra to make that happen. To go the other direction, however, you will need to use a casting operator. So if I wanted to go back, right? So if I wanted to say char A1 equals 65, right? So you're going to get an error because it can't implicitly go from that numerical value to the character. It can go from character to number. The way we get around that is that casting operator. Which is wrong casting operator. We use the casting operator to cast this integer into a character. So implicitly, C#'s not going to let you implicitly go from an integer to a character. You have to tell it explicitly. So you have to say, hey, this is what I want to do, so we're going to do it. So basically, that's what that casting operator does. So implicitly, C# like, no, you're not supposed to do that. Stop. But then you say, well, I'm going to do it. It's like, okay, then do it. So if I wanted to display again, just kind of drive the point further home and make sure the horse is good and dead. A1. Don't forget that. Not that one. Dang, I did it again. There we go. So A, right? 65 does equal A. But to go from an integer to a character, we will need that casting operator. With that being said, I'm just going to write this number so I don't forget it. I often do. Okay, with that being said, we'll go and comment this portion of the code out. We're going to move forward, and now what we want to happen is we want to display, using the loop, we want to display a sequence of letters, A through Z, and then Z through A. So I'm going to have my counter, integer counter. I'm going to set it equal to our starting point. For this instance, our starting point will be, let's see, 65. That's the first number you want to, or the A, right? So that's our quote-unquote our capital A. That's what we want to display, right? So we'll go and we'll start on that. So while count is less than or equal to 90. We want to do this, right? So we're going to say console dot write. I'm just going to do it right this time. Console dot write. I'm going to, excuse me, and I'm going to display want to display the number, right? So I'm going to display count. I don't want to display the number. I want to display the letter that corresponds with that number. So I'll cast it into a character. And so that's literally all we have to do to display A through Z, the capital letters. Oh, you know what I forgot again? My update. So let's. Don't forget the. Oh, well, you know what? We'll do our fancy trick again. Put our update in here. PostScript. Because we want it to happen afterwards. A, B, C through A all the way to Z, and then we stop. See? That's it. That's all you gotta do. Now, to do the same thing, I'm going to add a little bit here. So kind of space over there. Space out a bit. Okay. Console. I'm just gonna have an empty console.writeLine that'll give us a new line to kind of separate what I'm about to do here. So you want to do the same thing, except we're gonna do it in the opposite direction. So since count's already been declared, we don't need to redeclare. So we don't need to put that out in front again. But I do want to do a reassignment, if you will. I'm going to assign it to 90 this time, because we're counting from Z to A. And since the corresponding number to Z is 90, we're going to make it equal to 90. And again, same while loop. We will make some small changes, obviously. I'm going to copy it and paste it down here. So what I'm going to change here, I'm going to change that to 65, and I'm going to change it to greater than or equal to 65. So while count is greater than or equal to 65, we want to continue doing our code. Now, we don't want to increase count, because that's not what we want to do. We want to decrease count. So decrement. We want to use that minus deal there. So build it, and voila. A through Z, Z through A. It looks kind of daunting, and it seems very intense. Now, obviously, you could break the stuff up a little more. I like to make it as concise as possible. This is probably about as concise as you're going to get this code, having the character and the update within the WriteLine, or excuse me, the casting and the update within the WriteLine. It's probably about as concise as you're going to get it. So this is probably yeah, I would say, at least with what you have available for you. And that was, let's see, that was the second one on loops, number 2. Loops, I should say. That's that one. So I will comment that out, and we will push forward. The next one I'm going to go over is the third one. This is a little more about talking about it. I'll be doing the same. So you obviously know what a while loop is. Well, I would hope you know what a while loop is. So you have your while loop, and so in a while loop you have the keyword while. You have your condition. You've seen me write a few of these already today. You have your condition, and then you have the body. So the condition is the tester. That's what you're testing to see if it's true, to see if you're going to continue looping. Once it's false, you break out of your loop. And then obviously the body is where that's the meat of the loop. That's what's taking place. That's what you're iterating over. That's what you're doing again and again and again and again until, of course, our condition is no longer true. The difference between a do while and a while. So a do while, this is number 3A, by the way. So a do while, you have that condition, you have that little keyword do, our body, and then after the body, we test the while. We have our while the word and the condition, followed by a semicolon. So the body, so you're doing what's here, right? And then while this is true, so while your condition is equal to true, you're going to do whatever inside that body. The main difference between the two is that you're executing the body before you're testing. This is really good for, like, if you want to, for user validation instances. So you write the code. What's your name? I'll give you an example here. So we'll do the user validation example. Like, what's your name, right? Or better yet, we'll do one that's kind of like, no. Type in yes, right? So we'll say something along the lines. So do, I'm making a do while if you have picked that one. So we'll say do console write line. Don't ever forget. Anytime you ask for the user, anytime you read from the user, you want to have a prompt first. So you let them know what they're putting in. So type yes. And press enter. So I'm saying, I tell them to type yes and press enter. That's not a prompt. Then I read from them. String user equals console read line. So I read from them. You don't want to just simply read from them. You actually take the information they're giving you and store it somewhere because you're using that information, correct? The answer is yes if you don't know. So we take that information they give us and we store it into the string variable called user. Actually, I should declare this outside the loop since I'm about to use it in the condition. Alright. So they type yes and hit enter, and then I tell them to type yes and hit enter. Then they type whatever they type and hit enter, and we store that into user. So we hit this while user does not equal user does not equal yes semicolon. So for the do while, remember at the end of the while loop you need that semicolon. Don't forget that semicolon. It will come back on you if you forget it. If you're writing this and if you're writing your code in Visual Studios, the Visual Studios will give you a heads up. So just give you error here. Would read expect a semicolon, right? And it has a bloop bloop right there. That means you need to put a little bloop bloop, little semicolon. So then we exit the loop, right? Yay. So that works. So if I build this and run it, we have our prompt that prints out. Let's play this. So the prompt prints out. We enter our do while, right? The user is created. We enter our do while. We display type yes and then press enter, and then we wait for the user with that console read line. So if the user to write I don't want to, and then they hit enter, it's going to ask them again. Ask me again. Okay, fine. Yes. Okay, well, that didn't work, so maybe if I type it all capitals, yes, okay, good job. Then we exit. Okay, so obviously when you're testing, you need to be using we'll get into user validation a little later on, but for the sake of this, we're going to loop until we get this exact input, I should say. Once they type in that yes, so you saw it continue to loop and loop and loop and loop until we got the exact input, and then we finally continue on with our code until we exited the program. Yeah. So the difference, so like I said, the difference is we're doing this for, if I were to, for instance, make this a while loop, it would change some things around. So if I wanted to make this into a while loop, but do while, for this instance, the do while is a much better setup. If I were to make this a while loop, things get a little more tricky. So I use the same exact condition. I'm going to move a while loop here and get rid of the do. So right off the bat, you already see an issue, right? You got an error. An error is like we're using this unassigned variable. So now I have to give user a value. So I'll just make it an empty string. So now, okay, now it works. Obviously, I get rid of that semicolon. It's funny if it's a do while. So now it would work, essentially, but it's not efficient and it's not very good. We don't want to assign this bogus value. You want to have the user assign that. If it's the user's value, we want the user to assign the value. So that's why the do while is a little bit better. You could also, there's another way you do this. This is probably the better way. So if you want the user to define the value, right? We don't want to define the value. So what you take this and just copy and paste. So right now is we have redundant code. That's a no-no. You don't ever want to. You want to avoid redundant code at all costs. While yes, this works, and yes, it's okay, and yes, it does more or less solve the issue, it doesn't do it in a very effective and efficient manner. With while, the do while is much more efficient, much more effective, and that's what we want. We want it to be efficient and effective. So I'm going to do Control Z, go back to our do while. Voila. This is what you want to have. This is the way it should be written for that instance. So that's the difference between the while and the do while. For the while, the very first thing you do is you test. Whereas in the do while, the very last thing you do is test. Alright, so we'll move on to the next part for the for and for each. So for those, let's come this stuff out real quick. The difference between the for and the for each loops, besides the actual syntax of it. So obviously, remember the for, you'd have declare a counter or initialize a counter, excuse me. Set equal to 0. You can initialize outside and just say this is the one I'm using, but typically you initialize within the header of the for loop. So you have our initialize our counter, and while counter is less than something or greater than something, so our condition, if you will. So while our counter is less than 10 for instance. And then you have an update. So an update can be anything. Like I could say, it could be plus plus, it could be minus minus, it could be times equal to, so basically doubled each time. And then of course you have your body, the actual meat of the loop. So for each time we go up, we're going to say something along the lines of like you are in this display console right line display I. So hard to run that one. It doesn't work. That's why. Because we start at 1. We want to do the times equal. 1, 2, 4, 6, 8. 1, 2, 4, 6, 8. So yeah, that's how that works. For your for each loop, you could use a for each loop on, well, no. Typically they're used on arrays, right? So for and for each are often used with arrays. They don't have, well, for loops don't have to be used with arrays. For each basically are always used with your arrays. Fun fact, strings can be treated as arrays. So for each, and the difference between the for loop and the for each loop, a for loop is going to iterate over each index of the array of what you're doing, right? So for the big difference between when you're working with arrays, the for each is going to iterate over the index, so it's going to start starting from index 0 going all the way up to index whatever the last index is. So that's good to know, right? So that's pretty interesting. Whereas a for each loop iterates over the values of the array. So you're looping over the actual values, not over the index. So for each char, I'm going to call them C's, in A. So basically, for each character within this string, we're going to do something. I'm going to say display C, the character. And so it displays each individual character. I don't know if y'all knew that, but yeah, so you can treat strings as if they're arrays. So as you can see, instead of saying vertically or horizontally, now we display it vertically. So with these for each, you're more concerned about the individual values, right? So the S, the U, the P, the space, the I, the M, the space, the B, the O, the B, and then of course we end. And so for each loop, they're going to go sequentially. Excuse me. So we'll go over sequentially. So for eaches, you got to be careful with for eaches because they can't be things. So it's a read only. Also loop, so you're only reading it, so you can display it, you can use it for calculations, but you can't do calculations on the value on the item itself. To give an example, if I were to make this an array of integers, nine, 5, 29, 4. Right. Oh, so I have this array of 4 integers, 9, 5, 29, and 4. And so we're going to go over and we can display them. What we can't do, however, let's change this to an int. What we cannot do, however, change this to v for value, is we cannot change them. So we can't say v minus minus, right? You're going to get an error. It says cannot assign to v because it's a for each iteration variable, which means is you can't actually, it's a read-only thing, so we can't write it. So we can't write anything to it. We can't miss it equal to anything. We can't change the value. We're going to get it. It's going to block us from doing that. We're going to get an error. However, what we can do is take that value, if I'm not mistaken. Let's see. So, for instance, let's say we wanted the sum of all these, right? So, int sum equals 0, and I'm going to take our value. Excuse me. I'm going to say sum, and I'm going to plus equals our values. So with each value, we can add that to sum. So you see, we have no errors right there. Console. Yes. And so we can, I'm going to simplify these numbers a little better so we don't have to. So math is easier for us all, right? So 1, 3, 5, and 4. So that's what 7, 6, 13. It should be 13. Voila, voila. So anytime you're doing things of that nature, like you're adding them together, a for each is perfect for that. It's more efficient than a for each because it's not creating these variables that we're going to have to throw away later on. It just takes them and then takes the value, adds it to sum. Takes the value, adds it to sum. It's going to go down the line. It's going to go sequentially, so it's going to go through. It'll go through 0 to whatever the end is, but it doesn't care about the index value. It only cares about the value itself, the value within the array itself. And that's the big difference between a for and for each. Moving forward, let's see here. Can you think of a scenario where a while loop works, but a for loop does not? So, a great idea about that, or a great example would be where a while loop would still work, but a for loop wouldn't. The simplest one is a while loop that is waiting for this. We go back to our user validation one. It's perfect for this. Or we have this do while. We cannot turn that into a for loop. There's literally no way to turn this loop into a for loop. There's no way you could do that. So anytime you're looping words, you're waiting for a value to happen. Or even if you were to do it, so I made user integer, right? And they looped until they put in 0. So every time, so they can continue parse. So we'll continue to read from them, excluding, just ignore the here. We'll continue to read from them as long as they put in that, here we go. 0. So we're going to continue to loop until they hit that 0. There's no way to turn that into a for loop. Because, I mean, we want this to loop indefinitely, if you will, until we get the, excuse me, until we get to the for loop. You could use a break and whatnot, but you don't know how many times you're going to loop and all that sort of thing. So there's that would be, and there's a lot of other instances. That's just one that popped in my head first. Yeah. That's what we wanted to do. Yeah. So moving forward and onward and forwards. So that covers the 3, A, B, and C. Moving on to 4. In relationship to looping, it's useful to understand the following operations: the postscript, prescript, both decrements and increments, as well as compounding assignments such as the plus equals and divide equals, etc. 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 So A says, what's the difference between the plus plus before the I and plus plus after the I? We've already kind of go over and over that earlier. That's just the prescript and postscript. Obviously, so when you have a line of code and that postscript, so that I plus plus, right? So I plus plus, right? So that's a postscript. So everything on that singular line of code, on that, so before and after, or excuse me, before the semicolon and after the last semicolon, anything on that line of code, that's the last thing that takes place. If the pluses, if it's a prescript, and our pluses are in front of the AI, that's the very first thing to take place. So that's the very first thing that happens. So that's important to understand as well. For loop doesn't matter. So in a for loop, right? So we'll go back to our for loop up there. Get rid of these. So in our for loop, Control KC, that I had written up here. Here it is. So if I were to make this a plus plus, right? So I plus plus, it doesn't matter if it's plus plus first or plus plus afterwards. It doesn't change anything. If you like to think of it, this is one line of code. You could think of it like that. So just like if I were to write it down here, it wouldn't matter if I wrote it first or last. So if we go back to which one was that? This one. So remember, up here it doesn't matter if it does matter up here, right? Down here it doesn't matter because it's essentially by itself on a singular line of code. If you go, we'll go back to one of our counters here. Yes, so it's kind of like this counter here. So you see how that counter's on a line by itself. It's the same thing. This update is on a line by itself. You can think of it like that. So it doesn't matter if it's before or after it. It's a prescript or postscript. If you were to change this, I showed this one before. You could use, instead of saying, for instance, you wanted to display every even number, right? So I'll display every even number. If I want to display every even number. Very simple way of doing that would be starting at 2, from 2 to 10, right? You say, where's my button? There we go. So I times 2. So we're basically skipping the iteration. So this would only iterate. So when every time it iterates, we multiply times 2. So 2i times 2, or 2 times 2 is 4, 4 times 2 is 6, or 8, and so on and so forth. Excuse me, we're doubling. So we want to double the number every single time. We iterate. So it would look something like that, 2, 4, 8. We could even say 100. Not 1,000, 9, but 100. So as you see, it goes from 2, then it goes to 4, 8, 16, 32, and 64. And once you double 64, that's 128. So that's 128, right? So that's beyond our 100. And so, I mean, and you can do that with any way. So if you want to double it each time, each iteration, you're wanting to double it. So you can do that. It's perfectly legal to update in that manner. So basically, it's only going to iterate when you iterate. For this instance, we're going to go through it, and we're going to start at 2. We run the 2, test it. 2's good. So, like I said, so our initialize I at 2. Test to see if that's true. It is. We go in. We display 2. Then we times 2 by 2, which is 4. Test to see if it's still true. 4 is less than or equal to 100. We display it. 2 times 4 is 8. Test to see if 8 is less than that. It is. Display, yep. And then we continue to do that and just kind of go through this loop until we get to that 228 value. So we're at 228. We test to see if 228 is less than or equal to 100. It is not, so we exit the loop. So that's how that works. So basically we're skipping a lot of numbers in between those numbers. What's next here? So then we are into the 4C. With respect to a while loop, where you're using a counter variable for iteration, does it matter where in the loop do you increment or decrement the counter variable? I would say it does matter where you do it, mainly because not for the actual looping itself it doesn't matter, but if you're doing something that depends on that counter loop, which usually you are. If all your work, if you're just counting, like, I'm going to do this number of times, for instance, I'll go on instead of, I'll write this out. So while, let's create a counter for it. So we have our counter, right? So while counter is less than or equal to, I don't know, 12, just to give it a varied number. We want to console.writeLine. We want to display asterisk. Increase our counter. So it doesn't matter where this counter, we're incrementing the counter. Put a space here. So we run through it. We're going to run through it 13 times essentially. We'll change this to 1, so it is 12 individual times. Oh no, we'll 0, and then we'll just make it. Let's make it 12. So it's going to increment 12 times, starting at 0, going to 12. Let's say it's 12. We're going to exit the loop. So we get 12 little asterisks here, 12 little stars. Display 1, 2, 3, 4, 6, and 12. Yeah. Now, if I were to change this, or if I were to move this up to here. By the way, the tabs don't matter. That's just for your and my sake. The computer doesn't care for the computer, and the compiler don't care about the white space. They can make this happen without it. That's mainly for us, for our readability's sake. Same. Doesn't change in the least. So for something like this, it doesn't matter whether it's at the beginning of the loop or at the end of the loop. Now, where it might matter, or where it would matter really, is are you trying to, when you're displaying, right? Are you displaying the number? Are you doing something with that number? sum. So for instance, if we're adding all the numbers together. Generally, yeah. Okay, so equals 0. So while it does for the functionality of the loop itself, does it matter? No. For the functionality of what's happening inside, it may or may not matter. So, does the behavior change? So we're going to our. So that's where the next one is. Does the behavior change the? So does it change? It doesn't change the behavior of the loop necessarily speaking. It will or can change the behavior of what's inside the loop. So we have this. If we are having this running sum, if you will. So if we display sum plus equals counter, right? So we start at 1, and then we go all the way up until we hit 78. So what's happening is each time we iterate, we're adding our running sum to the counter, whatever the counter is. The counter is increasing by 1 each iteration. So in this case, the first thing happened is we increase counter by 1, and we added that to sum. If, however, you wanted to change that up a little bit, I'm going to run this again just so we can have it. I can have both of them up at the same time. I'm going to move this back down to here. Run it again. So you see it starts at 0. I'll bring up the other one. So we have them side by side. So with this one, you can see the iteration. It's 0. Come back here. 0, and this one starts at 1. And then this one ends at 66, and this one ends at 78. Now, the numbers are essentially the same, so I can just move this down, and the numbers all match up. But that's so it would really depend on what you're trying to achieve and what exactly you're doing. Obviously, it changed the behavior of the code where it was, but it didn't change the behavior of the loop itself. It still ended and started at 0. It still ended and started. So, for an instance, get rid of that, right? So it starts at 0, ends at 12. If I were to move this, it still iterates the same number of times. The loop does. Do it again. It starts at 12, right? So it went from 1 to 12, and the other one went from 0 to 11. It's just, it changes the behavior of what's inside the loop, but the actual loop itself, it will still loop 12 times. It's just how, if you're interacting with that value, if that value is just a counter, simply all it does is count through 1 through 0 from one number to another number, and then once it reaches a certain number, then you end the loop. If that's all that number does, it doesn't matter where it's at. You can put it anywhere inside your loop that you want to put. However, if you plan on interacting with that number, plan on using that number for calculations or displaying the number, where it's at will change the way, or what it rather is displayed, what number it is. So that's just something to keep in mind when you're writing these loops with counters, or with the terminology she used. Yes, with the counter variable. So just be aware that it will loop the same number of times. It doesn't change the loop itself. It doesn't change. The interior of the loop may change. So just be aware of where you're putting it. And yeah, it's a good thing to look out for. So it's kind of like a yes/no kind of answer on both those, really. It's kind of like a and. All right, so moving on to loop still within the loop, but number 5. Oh, it's number 5. Okay, so number 5 asks, what is the significance what is the significance of the break statement when discussing loops, and what does it do? So we're not talking about the switch break, we're talking about the break statement within loops. if you all have kind of gone to any of my sessions or any of my previous videos, you've known that when I write while loops, I like to write them with I like to write infinite loops and use a break statement to start off with before I actually define the actual condition. Just because it's easier for my mind to comprehend. It may add a couple extra steps, but to me it makes things easier. It helps me to concentrate on the meat of what I'm doing. At least that's my excuse. So, for example, while true. So, when you write while true, this will loop forever and ever and ever and ever until your computer dies or runs out of memory or runs out of battery or power, or until you exit the program, or till you give it some way to stop. And some way to stop is the break statement. A break statement will break you out of a loop. So, again, I'm going to use a counter here. And I'm just going to write a very simple loop here. Count equals 0. Count plus plus. Actually, so we have our console. We're going to display the counter, and then after we display the counter, we're going to increase the counter. I'm going to add that. We're going to increment counter by 1. So if count equals, so if it equals 10, equal. So if it equals 10, so if it equals 10, so count equals 10, I want to break out of the loop. Alright. So, that was supposed to be at the end of the loop. My apologies. So basically we're going to display the counter, then increase it, and then test to see if the counter is equal to 10. And if it is, we break, otherwise we continue on with the loop. Okay. So it goes 0 to 10. 0. Oh, right. Forgot. I wanted to. We're going to comment out that if statement as if it doesn't exist, right? So right now, I'm already going to get a warning from the system, and it says I have unreachable code. I'll show you what that means in a second. So I'm going to run this again, and as you can see, we're continuing to display and increase forever and ever and ever and ever, and it will continue to go on until my computer dies, or some other things happen. But I'm going to stop it because I don't want that to happen. This would be a very long video if we do that. I don't want the video to be that long. So I'm going to uncomment that, and we're going to see what happens. So as soon as, so if you notice here, so we've increased, after this line runs, we increase our counter, and then we test our counter. So the very first iteration, counter 0, we enter in while true, so we're going to loop forever. Console.write line, we display 0, and then increase 0 by 1. Then we test to see if 1 is less or equal to 10. It is not. So we skip over this block of code, hit the end, go back, it's still true, and then continue to go on through until we get to 9, right? So we've displayed the number 9, or excuse me, we displayed the number 8, increased by 1, so now it's 9. 9 is not equal to 10. We go back through, hit our end of our loop, we go up to test our true. It is true. Obviously, true it is equal true. Display 9, increase 9 by 1, it's now 10. If count is equal, or excuse me, 10 does equal 10, so we enter into here with this break statement, and then we break out of our loop, getting to the console.writeLine. And that's how we get to here. So we see it goes from 0 to 9. It does not display 10 because we break out before we display 10. And we display you're free. And yes, that is the wrong EOR. For any of you literature and English majors. What was I doing? So that's the break. So basically, that break statement literally breaks you out of the loop so you can continue on the code. Yeah. And then you have the continue statement. So that's number 6. What is the significance of the continue statement when discussing loops? What does it do? Basically, what a continue statement does, it stops you at a point, right? So in this one, I'm going to change this up a tiddlywink. So integer sum, get rid of that. Excuse me. I'm gonna write that same console.sum plus equal. Oh, I forgot that. Count. I'm going to. You know what? We will keep it like that. So let's see. Plus equals count. So basically, we're going to be displaying the sum plus the counter. Well, after we increase the counter by sum. Excuse me. Actually, you know what? We're gonna get super fancy over here. But I don't. I'm gonna make this 100. But I don't want to. I want to add all the numbers from 0 to 100 together, and I want to display them as I add them. So this running sum, I want to display them as I add them. Actually, you know what we're gonna do? Yeah, we'll do it like that. So once counter count, if you will, equals 100, we're going to break. But but I don't want to add anything beyond 78 or 70. I want to stop at 70. I want to stop adding, but I want to continue to loop. This is a weird thing. This would never happen. I don't see where you'd want to do this, but if sum is equal to 70, you know what? Is greater than or equal to 70. That's not greater than 10. Greater than or equal to 7. So if sum is greater than or equal to 70, I no longer want to add sum to it. Yeah. Actually, yeah, I don't want that there. Oh. What are we doing then? So, if I don't want to do any of this stuff down here, I'm actually going to. If I don't want to do any of that stuff down there, I'm going to put a counter up here at the top, or increase the counter up here at the top. I'm actually going to change this. We'll get rid of this break statement. So, what's happening here now? I've gotten this all written out. So what's happening, we have the counter, we've initialized the counter equal to 0, we initialized the sum equal to 0, and we're looping as long as count is less than or equal to 100. And the very first thing we do on our loop is we increase counter by 1. Then, if our sum is greater than or equal to 70, we're going to continue. If it's not, we're going to display sum plus equals count. Now, what does that mean? Also, I want to do this. So the very first thing is once we enter our loop, or the body of our loop, first thing we do is we increase counter by 1. And then we display counter with a colon and a space. And then we run this if statement. So if sum is less than, or excuse me, greater than or equal to 70, we run this continue statement. I'll go back to that in a moment. If the statement is false, if the statement is false, i.e. sum is less than 70, strictly less than 70, we continue. Or excuse me, not continue. We move on with our code. And then we hit this console.write line, which takes the sum and displays the sum after it's been added to count. Or after count's been added to it, I should say. And we continue looping until our count is less than or equal to 100, or excuse me, no longer strictly greater than 100. Once it hits 101, we're going to exit and display this. Now what continue will actually do is it goes straight from, it stops the code, essentially, right here. It ends. And we don't run anything down here. Actually, anything down here doesn't get ran. We go straight up to the condition and test our condition. And then if our condition is true, obviously we continue looping, otherwise we exit. So with that lengthy explanation, voila. Let me do one little bit here. So as you can see, sum is greater than 70. So since sum is greater than 70, we are no longer after that point we no longer display any other number, any other sum. So that's sum. So if I were to display this, if I were to display the sum down here, so you see, sum stopped being, never changed. After 78, it stopped. It stopped changing. Yes. So once we get a number that was greater, so once sum became greater than 78, greater than a number than 70, we no longer ran this line of code here. We only ran the, back up here, we only ran the first part. So only this was being ran. Before it was this plus this. And then once sum became strictly greater than 70, or became greater than or equal to 70, we started to run only this until we get a zero loop and run this. So that's kind of how the continue and break work. Alright, now to input validation. So why do we need user input validation? If it's not obvious, which I hope it would be, but if it's not obvious, input validation essentially protects our program from dumb users and malicious users. People who are going to put things, for instance, you want someone to enter the number 1, and instead of writing 1, they write 1. Now, technically speaking, yes, those are the same thing. Technically speaking, 1 and 1 are the same. For the English language, have the same meaning, right? But for a computer, a numerical 1 and the word 1 are very different. 1 is an integer and 1 is a string, and they're not the same thing. They can't be used the same way in C#, or most languages, to my knowledge, at least. So that kind of help protects us people from who want to be malicious and break your program, or people who just don't know any better. Yeah. So there's that. So it kind of helps. It just kind of helps to strengthen your program, which is very good. You'll use user input validation as you go on. If you continue writing code past this class, you're going to use user validation quite a bit. So it's a good thing to learn. When you need to, this is on to number 8, by the way, if you're following along with me. When you need to ensure the user is providing a valid answer to a question you have presented, what is the general strategy of how you accomplish this? Does your answer change in the following scenarios? So, to answer that main question, what's your general strategy? Yeah, I would say yes, it does change based on the scenario you're going here. When you're expecting a response for a string, you could do things, excuse me, there are different ways you can trim up the fat, if you will. You could get rid of the extra spaces, so if they write, I'm going to put quotes here, So if they write blah 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 space space, this whole thing is their input. You don't want to use that space space though, because you don't want to have to anticipate their space space. So you can use there's a method that I believe there's a method for C#. Another one is Python. I believe there's one for I'm fairly certain there's one for C#. I don't know off the top of my head. I'll have to look that up. There's one that will get rid of the extra spaces before and after. So you put a space here and spaces here. It gets rid of that white space basically. It only takes what they actually entered. You also would want a good rule of thumb is making everything the same case, or you can use the camel case or all the different cases. There's methods to change the way that the word is displayed, if you will, or the string is displayed. Excuse me. Excuse me. So, a good rule of thumb to simplify the testing process, you just make all lowercase or all uppercase. That's a good way of doing it. That way, no matter how they enter in their response to whatever you're asking, it's always the same. And obviously, like, you can do things like, for instance, the name, you can have it capitalized. That way, the first letter is capitalized always. So you basically take what their response and capitalize it, and you set that to their first name value. These are little things to do. I just kind of make sure that everything's the exact same thing. And there are ways to test to see if it's not a number. Like if you want them to write Heim, or you want to write the first name, right? So you just trim the outside spaces, the beginning and ending spaces, the white space, if you will. And then you make sure, like, if it's a name, for example, you want it to be capitalized, you use the capitalization method. Yeah. Off the top of my head, I'm not sure what those are. Sorry, but it's a quick Google search. Just type in capitalizing method for strings, C#. Write that into Google, and it'll pop up real quick. For numerical values, that's that triparse. Using triparse will work perfectly, and actually works for character values as well. Triparse does work for characters. So, I say, this is very silly and useless code I'm about to write here, but hey, it displays exactly what you want to do. So, you ask, how much does an ice cream cone cost? Right, and then we're gonna create our double variable to store the cost. Do a while. So another thing you always want to do is you always kind of want to put it into a loop. Well, not always. Usually you don't want to use a loop. You want to loop over their inputs. You want to continue looping until you get an input that works. I'm going to move my double up here, or my cost rather. So I want to create a bool, test, and I want, what else do I want? That's all for now. Excuse me. So test equals, so remember how try parse works. First we display. So we want it to be a double, not a do but a double. Try parse. So double dot try parse, and within that try parse, we get our string. The first value you're going to have is a string, and that string is going to be their console.writeLine, or excuse me, readline, comma, out, there, the keyword out, and then our result, which is cost, and over here, semicolon. So here we are. Asking how much does an ice cream cone cost? We test. We run this test, right? And then we display test. So while test is true, actually, excuse me, while test is false. So while test is false, or not test, right? So while test is false, which is what that little condition means, we want to continue to loop. So first thing we do is we prompt them, how much does the ice cream cone cost? And then we test to see then we take what they entered. We try to parse it into a double. If it is possible, we set test to true and set the value to cost. If it is not possible, we set test to false and set the value, the out value, to 0, or sorry, my brain just stopped. The default value, which in this case would be 0. Sorry. Excuse me. Ooh. These allergies are killing me. So how much does an ice cream cone cost? Money! Makes no sense. Let's go ask again. How much does an ice cream cone cost? I'm going to say $6.50. Expensive ice cream cone. $6. Oh, you know what? We can do one, but we'll use our little modifiers here. Here's a currency. So now it's going to display cost as a currency or something. Little thing. I'm not sure if this is even on there, but yeah. So if you remember back these little guys here, you can make it a C for currency. So it'll display it as currency. There's also a number of other ones. There's number, which will, I think, gives it like the little commas at each for each. How do you know? And percentage displayed as percentage, and so on and so forth. Or, excuse me, P to show it as a percentage. Super useful. Build and run. Okay. There it is. So how much does ice cream cone cost? It costs $6.50. And now, cost this displays as currency, so that's where that comes into play. So there's a fun little deal. And that's kind of helps to validate what you're putting in. You could also, what was the other? That's the same thing for integer, right? We just have to make sure we change everything. party. Then. So obviously, because 10 is not an integer, like what we're looking for, that's already an integer, then. So, yeah. So yeah, there's 10. Yeah. There's 10 here, so there's 10 in your party. And then for characters, right? So we can actually use that triparse as a character. Of course, we have to change this to a character. And say... Are you going to pass this exam? Yes or no? And I hope you all say yes. Alright, so are you going to pass the exam? Change my response here a bit. Have a little fun with it. If cost equals char dot to upper cost. So what this little line of code does, it actually takes cost, whatever the cost is, sets it to a uppercase value, regardless whether they put a lowercase or uppercase. Actually change that too, or as well, excuse me. So that way you don't have to test for both upper and lower cases. That helps out a lot. So if cost equals yep. I knew you would. So what's going to run here is if they enter a Y or an N. So basically what we're doing here, put a space here. So we have this, we initialized the cost, or the character called cost, and the boolean called test. At least we did not initialize. We declared the character cost and declare the boolean test. We enter our do while loop. We prompt the user, are you going to pass this exam, yes or no, or y and rather. Then we test. Then we run this try parse here. We take what they entered as a string. We try to parse it into a character, and then if we are capable of parsing what they put us into a character, we enter in cost, and then we set that to cost, and we let's see if I can do this. I'm going to rise something here. Nope. Okay. I just want to try something real quick. Oh, that's why. Yeah. Okay. Anyways. Yes. So we do that like that. There's other ways you can do this. So this is one way. Obviously, you can do try parse. Another way, I'll go and run this just so you can. It's not running. So are you going to pass the exam? Yes, I am. Now notice I've put in a lowercase y. I knew you would. It still works. It still runs the uppercase situation because it's of this here. We take this to upper and it makes it uppercase and sets the uppercase y to cost. Or now uppercase y to cost. And then we test. So that's just one way to do it. You could also do something along this line. So we can get rid of this entirely. Well, I mean, that's probably the simplest way to do it. There's other ways to do it. What you could do is just take the very first variable, the very first character, I should say, of their string, whatever the string they entered. And the way you would do that is you would. It's going to go into an error, but I'll show you how to do it. So you get the first character in a string. You do it just like if it were a. You do it just as if it were a. All right. So you have that the bracket 0 is the first value in an array, right? So the bracket is 0 next to a string. The name of a string, or even the console read line, is the first character in the. Is the first character in our string. So I mean, you can just test it with that. But I mean, it gets kind of your test gets kind of funky and wonky. So there's that way to do it. That's probably this is probably the simplest and surest way of doing this for this instant, right? So there's more than one way to do everything. I would say this is the most efficient way of doing this, the simplest and the easiest way. But I mean, at the end of the day, it's up to you. You could have gotten rid of this, and we could have tested for is cost is equal to uppercase y or cost is equal to lowercase y. But they can of course do the same thing down here. But it's easier and things happen better. Do it like that. Let's see. So, what number was that? That was 8C. So let's move on to 9. Number 9. Yes. Generally, when writing programs, except ignore letter case. Oh, that's. Oh, we just did number 9 actually. Do you accept that? Can you accomplish this behavior? So that's how you accomplish behavior. So that's what I was doing up there. That 2 upper. running that char.to upper. So this line right here makes it so that we can accept both lowercase and uppercase values because we only test the one value. We're only testing the one uppercase value, but now we can test both values. We can take both values, if you will, and basically, no matter what they give us, we're going to make sure that it's an uppercase value. Can you see a scenario where you would never want to ignore letter case or make modifications to the user? So, an instance where you would not want to change the case that they've entered would be, for instance, a password is probably the one instance where everybody kind of knows and recognizes the password is case sensitive. So, many passwords are case sensitive. So, if you have a case sensitive password, you want to make sure that you're not changing the case that they've entered, because that's important, because you want to test whether or not. So, a good example is, we'll go and write this password. So, string password equals, and we're going to call it password GHE. Everybody can remember. Convid 19, right? So we'll say that's your password, right? Or password. So then you say start right line. And then string user. And we're going to declare the string user. We'll prompt our user. Enter. Enter the password. Let me say user equals read line, excuse me. So we're going to read from the user. And now we're going to test to see if password. So if user equals password, then so if they are the same variable, so we're going to compare them to. So it will compare to make sure they are the same. In fact, the same input, same thing, same string. Here we go. There's a word you don't want to use. If they are in fact the same string value, then this is what's going to happen. We're going to say else. D9. I hit the wrong button. Here, didn't I? All right. So, well, here. I guess we don't need that. No. This is very simple, very basic, but basically you have this variable that holds this string variable. In a real life, I don't think I've gone over constant values, but I would make this a constant. So that way it can't change, right? So this is a constant value. So I don't know if y'all have gone over constants, but constants is a value that you declare once. You initialize once. And once you initialize it, it can never be changed. And you also have to initialize it. So you have to have the value. You have to initialize. You can't declare it and then assign it. So you have to do both the declaration and the assignment at the same time. So we initialize the string, the constant string PW, and we initialize it as such. Then we declare the string user, prompt the user, read and store from the user, and then we test to see if the user's input is equal to the PW string, our password string. If it is, we display this, we may enter. Otherwise, we display this. So enter the password, I'm going to say blah, 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 blah. Access denied, right? Then I run it again. Try to log in, if you will, again. So remember our password is, this is the actual password, right? ComGood19. Now, let's say I'm going to use a lowercase v, because I forgot it was an uppercase v. Access denied, because the uppercase and the lowercase have different values. So I'll run it again. I will log in again, if you will. So it's on bid 19. I can enter. Yay! So that's a very, very, very basic kind of how passwords work. But so that's a situation where you would not want to change the user's the casing that the user's entered. So that was 9B. 910. Expecting the number input from the user choosing try parse. How can you tell if the user entered the number 0 opposed to having entered a non-numerical input? So let's go back to our try parse. If you remember, try parse sets the output variable to the default if it cannot parse what the user input. If it cannot parse the input value. Yeah. So we'll go back to this one. We'll go back to our cost. Yeah, we'll do this one again. Alright. So we'll change this to an int, just because integers are easier to work with. Change that to an int. Enter a number. So, that question is basically asking the number, what was I say, number 10. It's essentially asking, so they can put in, so 0 is a number. There we go. Remember that is not, is so 0 and above, right? How do we test to make sure that's not 0? Because we don't want 0 to be included with our answer, correct? For this instance, so our try parse will actually be set to. So they enter a value, whatever that value may or may not be. Then we try to parse it into an integer. If it can be parsed into an integer, then this is set to then this is set to false, and this is set to the default value, in this case 0. So if you can, this is set to true, and then this is set to that value. So basically it's asking, how do we tell the difference between a 0 and a user's input 0 and the actual 0? So, oh yeah, there we go. Enter thing. Enter 0. Enter number. Enter. Here we go. 0, because I want to include 0. And above. Enter 0 or above. Or above. So, we're asking, 0 is a valid input. However, the way it's written, it'll take a valid input that is, it'll take 0. We don't want it to take 0. We want it to not include 0, basically. So how do we do that? How do we stop it from including that 0? And basically is, you'd have to have a while loop. You'd have to change your while loop. This would be, is you, instead of basing it solely on the input value, you include or base it off of the Boolean value. Excuse me, input value. So like this. So while excuse me. While cost is greater than or equal to 0. Or, excuse me, less than 0. So we're going to loop until cost is greater than 0, right? Which is good. The problem is, if I enter something that's not a number, then we're gonna run into an issue. So I'll go and give you a demonstration of how that would look. So -4, we loop. -100, we loop. I enter the word 1. It stops. Why does it stop? It shouldn't stop. That's not a proper answer. But what happened is, it changed cost to 0. And now, since cost is less than 0, right? So, or since 0 is not less than 0, 0 is 0, we exit our loop. Because once our conditioning equals false, we exit the while loop. Or in this case, do while loop. That's a problem, obviously. So a quick way to solve that is, well, this is so, or not test. So basically, while our test is this, or that should be and, or no, or. So while they enter a number that is, so we'll run it again, and I'll just talk about it as we go. So enter 0 or above, right? Enter -4 again. Test is actually true. So when I enter -4, test is set to true, so that would make this false. However, so this side is false, but this side is true, or excuse me, this side is true. No. Rewind. This side is false, but this side is true. Is that right? Yes, that's right. But they're both false, I should say. Give me a moment here. Okay. This is true, this is false. Because this is true, and this is false. There we go. Sorry, oh. That's not what I wanted to happen. Baby, come back. There we go. So, test is set to true, therefore not test is false. If that makes sense. And then if you were to do cost is less than 0, that is true. So we have true and or false, which is true. So to continue on with this, we're going to say 1. Now, the word 1 is technically true, but test is going to be set to false, or yes, test will be set to false. So non-false is true. Boom. This is now 0, by the way. So 0 makes this false, but this is true because test is not false. So not false is true. So now I enter a correct value, right? So I'll enter the real. I'll enter 0. So I'm putting in 0. Test will be true. Excuse me. Test will be true. Cost less than 0, and then cost is 0. Therefore, cost less than 0 is false. Not test is false. Yes. And so that's how you get around that. That was number 10. There you have it. Alright, so on to arrays. This is going to be a long video. On to arrays. How do you perform the basic array operations? Declare an array, getting a value of an element in specific index, set or change a value of an array element or at a specific index, and find out how many elements of an array can be stored in total. So we're going to do those kind of all together. So, declaring an array is very simple, right? Excuse me. So, an array of integers. We'll work with integers for all of these. For this first, number 11 here. Very first part of the syntax is the declaration. Not that one. That little deal here, these little square brackets, lets C# know that it's an array. And the integer in front of it lets you know that it's an array of integers, because as you all should know, I should say, arrays in C# are all the same value. You can't have an array that holds integers, strings, and doubles, for instance. That doesn't work. They need to be. They need to all have to contain the same data type. Each element of the array contains the same data type. So, declaring an array. Array 1. So that's the simple declaration. Boom. Array 1. Array 1. I'll declare 2 of them actually. So I'm going to declare 2 arrays. Alright, so we've declared array 1 and we've declared array 2. Array 1. Now there's a couple ways you can do it if you know what the values are actually going to be, right? So we have 23, 23, 4, 82, or 81, excuse me. Sorry. So I'm actually going to do some little moving around here. So, as you see, I'm getting an error all the time here. You get a bunch of errors, just like they can't do this. This isn't working. The issue is you can't declare an array like this. Once you declare an array, you can declare an array like this, but you can't go through and write this afterwards, right? So if you're going to declare it in this manner, you have to do the declaration and the assignment at the same time. So you see now all those little error signs have gone away. This is value, so that's the first way to assign them. You know what the values are, and that's how I'm going to assign them. The second way to do it is, again, I can declare. So if you're going to, if you wanted to simply declare it and then assign it later on, you would say array2 equals keyword new, and then we're going to say integer and then give it size. We're going to call it size 4. Okay. So we have this new, so this is what this actually allocates the memory, right? So in this one, we're both allocating the memory and storing values within it. In this one you're actually doing. So this one we declare that the array exists, and then we allocate the memory for the array and store zeros in each of the elements. I think, let me try something here. I'm not sure if this works, but we're gonna see if it does. Just curious. Nope, it's not gonna work. Okay. So there you have that. Now, so if you want to declare an array, you don't know the size, or excuse me, you know the size of the array, but you don't know what the values within the array are going to be. So you don't know what the values of the size or the values within the array are going to be. That's when you would do something along those lines, where you just simply create the array without assigning the individual values. You just create the size of the array, right? So that 4 represents the size of the array, or the length of the array, or the number of elements within the array. So there are 4 elements within the array. Now, when you want to, let's see, we declared it. You want to get a value of an array, of a specific element. So it's on the right line, and I want to display the second element within array 1. The second element would be 1. So if you remember, our indices are counted starting with the number 0. So they count from, so this is 0, 1, 2, and 3. There are 4 elements, or the size is 4, but the number we're counting, with the reference number, if you will, is 0, 1, 2, 3, or 0, 1, 2, and 3. So area, or array 1 at index 1 is actually, that value is 4. So that's how you refer to specific elements within the array. To set or change a value within the array is the same process. So array 2 at 0, so that's the very first element in array 2. If I were to set that to set it to, I don't know, set, or Yeah, set to 7. So now this array looks like it has 7, 0, 0, and 0. That's what that array looks like currently. I can go through and set them all. Array 2 at 1 equals 8. Array 2 at 2 equals 92. Array 2 at 3 equals 1. Now, so now we've been, yeah, and I can change, so we'll go array 1, right? Say I want to change whatever these values are at, I'm going to say, since that last one is 0, I want to change that one, so I'm going to say array 3, or sorry, array 1 at 3, or at index 3. I want it to be a 80, I want it to be an array 2, I want it to be equal to array 2 at 2. So now that's going to be a 92, because array 2 at 2 is 92. And there you have that. Find how many elements an array can be stored in total. So how many elements can we store? That's pretty simple as well. You just simply say console writeline array 2 has array 2 dot length. So I'll run this bit code there, just finish writing. So remember, displaying the first, excuse me, not the first, it's technically the second element, the first index, or index 1 I should probably say, is for array 1 is 4, that's why you have that first 4 displayed. And then array 2 has 4 elements, because we did array 2 dot length. So that dot length is how you get the size or the number of elements within the array. And we know why that is useful for the for loops. That is number 11. Okay. And filling an array within constant values. So if you want to fill an array with constant values, for example, we can do, we'll do the example with ones. For, say, int I equals 0, while I is less than array 1 dot length I plus plus. Again, you can put the plus plus at the beginning or the end. It does not change. However, yeah, it's easier just to remember I plus plus. So I plus plus. And then we're going to set array 1 at I equals, we'll just draw 1. And so what's going to happen is we're going to iterate over the array 1, or the first array, or array 1. We're going to iterate over array 1, over the indices. So at index 0, right, we're going to set I to 0, so I is 0, it gets 0, so this becomes 0. And then we go say, excuse me, and then we go through it and we say, okay, now it's 2, and 3, and 4. So index 1 is 1, index 2 is 1, index 3 is 1, and index 4, well, I4, when I is equal to 4, 4 is no longer strictly less than the length, which is 4, they're equal, we're going to exit a for loop. So that's how you do a constant. And for number 13, how will you do incremental values? So 1 plus, right? I'll probably say that starting with 1, I would say. So if you want going from 1 and up, right? So I plus 1. So this doesn't change the value of this line of code, won't change the value of I, but it reads the value of I, whatever it may be, and then adds 1 to it. It takes that value and sets our array at whatever our index are at equal to that. That's how you would do that. So that would get you, so for 0, right? For the first iteration, I is 0. 0 is strictly less than the array.length, which is 4. So the array at 0 is equal to 0 plus 1, which is 1. And then for the next iteration, and then we go to here to the update, I plus plus, which means 0 plus plus, which is 1. So now I is 1. Then we move back over here, tested, 1 is strictly less than. Array at 1 is equal to 1 plus 1, which is 2. And then we set that equal to there. So, and then we continue on until we get to until we finish, which is once array or I is equal to 4. And that's when we exit. What's the difference between the array index and value? So I'm pretty sure I've got this a couple times at this point. So for this statement, we'll use this line for our explanation, if you will. So we have this one line. Array at index 0 is equal to 7. 7 is the value of the array element. Index, the 0, is the index of the array element. So you have these array elements, right? And for this instance, the first one is called 0. The first one will always be called 0. Index 0. Index 0. So your index is always going to be 0, and it's always going to be sequential. Index will always be sequential, meaning going from 1, 2, 3, 4, 5, 6, 7, 8, and so forth. So as you can see, it's 0, 1, 2, 3, and 4. Now you wouldn't necessarily have to assign them sequentially, but know that they are sequential. They are right next to each other. There are 0 through 0, 1, 2, 3, and so forth. The index will always be an integer. The value, the data type of the value, will depend upon the data type of your array. So for this instance, our data type is integer. If our data type is double, then that would change as well. Then all the values would be doubles. And the values clearly do not have to be sequential. Values can be whatever you put between them, as long as they are the correct data type. And I mean that's pretty much that is the difference between the two. I'm gonna skip over the 15. That's should be self-explanatory. For 15, I'll talk about 15 real quick. 15, what is the first index? It's index 0. What is the last index? There's a couple ways you can refer to the last index. You can refer to it as such. So instead of saying, if you don't know what the index value is, right, or the number, you can say so the array length minus 1. I'm fairly certain this will work as well. Let's see. Oh, no. That didn't work. Okay. So I guess that doesn't work. Never mind. So, if you want to know the very last element of an array, you don't know the length of the array, you can just simply say array, the name of the array dot length minus 1, and that will give you. See, now we don't break. Our doesn't break, so it doesn't say we're out of bounds, which, by the way, is the last answer. What happens if you exceed the bounds of the array? So what happens if you exceed the bounds of the array? If the array is -1 or any negative number. If you have any negative number in your, if you're referring for index, right? For your indices, if you have any negative number or any number that is equal to the length or above, it's going to be outside of your bounds, and you're going to have an error thrown at you. So you can see the error. Okay? Also notice that this works. Like, this doesn't break at compile time. I do get an error because we're starting on the error, a warning, because it's saying index could be a error. But as soon as I run at runtime, we get this exception saying index is outside of the bounds of the array. So be aware that don't do that. So save yourself trouble and don't do that. Okay. Number 16. How to display all the items on the array of an array on the screen forwards from beginning to end, or I don't know. Okay. So how to display it from the first indice to the last indice, right? Or index, from the first index to the last index, and vice versa. How to display them from the last index. So in that case, so again, for this one, you wouldn't actually, we can do a for each loop for this one, which I will do. Yes, so for each. Now you can do a for or a for each loop, but since we're simply displaying, we're not actually, well, no, it does matter actually. So we'll do a for loop, because it matters where we're starting from. So since it matters where we're starting from, this is, I will say this, int I equals, now we're going to assume that we don't know how long these are. Always assume that you don't know the lengths. That you want to be very dynamic in your code writing so that your code will cover many cases, not very specific. You want to cover as many cases as you possibly can. So, starting from the very first one, this is the easiest, relatively easy to understand. We're going to do the second array. So it's the same header as our first one up there. There's the one above. Differences, console. Now I could have actually done, before this, I could have we could have made this a for each loop, and I'll show a for each loop later in a moment. Right line. And array 2 at index I. So this will display every value within the array elements for every single element. If you want to do the same thing, I'm just going to copy and paste here and change it as needed. Paste. If you want to go backwards, right? So that's the thing. So if we're going backwards, our starting point is actually the very last element. And if you remember how I did it back up above there, I refer to the last element. We're going to say array2.length minus 1. So So our int I, right, is equal to array.length minus 1. So that's starting at the last element. So as long as I is greater than, instead of the length, 0, that's where we want to stop at 0. should be greater than or equal to 0. Then we continue. And then instead of adding, we're subtracting. And this will do the exact same thing, except in opposite. So, actually, you know what? Nice and neat and pretty. So as you can see, it's 7, 8, 92, 1. Now it's 1, 92, 8, 7. So here, our first little deal here, that's the front ways, right? So that's 7, 8, 92, 1. So if we scroll up here, 7, 8, 92, 1. And then from backwards, we see we started at 1 and went to 92 to 8 to 7. There's a little fun way of doing that. That's how you go backwards and forwards. That's number 16. Number 17. So the first occurrence, right? So for first occurrence, it's relatively simple. You're just gonna wait until you have write an if statement in the for loop that shows in this for loop. You're gonna in the body of that for loop, you would put in an if statement. If array2 at I equals whatever the value we're looking for, then you want to break out and maybe put a message saying, I found it at this, and then I found it at I. Or say, before you break, say, the value is first seen at I, and then hit your break statement so you break out your for loop. And then for the last value, you can do the same thing, except put it in here. Find all occurrences, then what I would do, I would create an array that is equal to the length of the array you're checking. Yes. No. Well. Yeah, we can do that. Actually, for that one, I'll use a for loop. For each loop, excuse me. For C, I'll use a for each loop. And D is basically the same thing as the first ones. The first occurrence, I'm assuming that what was meant there is the first index or position of that value. So that's why. So I don't know why she has D, N, A, B, and C, because they're all kind of doing the same thing. Or you just want to have a rule that says they exist, and then maybe count how many. For C, maybe you have a counter. Instead of breaking out, you just increase counter by 1, and then you say it exists this many times. Maybe that's what that's asking. For F, you do the same thing. If that counter increases each time. If the counter is greater than is 2 or greater than, that means you have duplicates. So then you flip it so that if that were true, you would display yes, there are more, there are duplicates, or maybe set a flag to true. if the same value x exists at the same position in two arrays. So that's, well, I'll show you that one because that one's pretty good. So this anywhere in two arrays. The value exists in one array but not the other. Okay, for those. Okay, so just so we can see what's in all these arrays, I'm going to display both of them. Alright, so we have an occurrence. One, they don't look the same. One doesn't happen in the same place. Okay. So I'm going to we're going to change this a little bit here. Actually, you know what? We'll start from scratch. Okay, so array 1, integer array, array 1 equals 3, 8, and 2. And then we have int array 2 equals 6. Eight, 2, 14. So, as you can see, we have 3 and a 6. These don't match up. These two 8s match up. These two indexes don't match up. However, there are two values of the same. One moment. Alright, and I'm back. Okay, so there's two values that are not the same. Or excuse me, you have two values that exist in both. However, the 2's are not at the same index in both arrays. So let's see, what was I? We'll do G. If the same value x exists in the same position in two arrays. So that would be there's only one occurrence of that, right? So for int I equals 0, I is strictly less than array 1 dot length. I plus plus. Brain's not 100%. I plus plus, yes. And then we're going to nest another array, excuse me, another for loop within this one. So for int j equals 0, while j is strictly less than 1 dot length, j plus plus. And so, let me change this to array 2, just for the sake of it. So we have our outside loop and our inside loop. So you can kind of think we're testing what's happening here is we're testing to see. Actually, we don't need this loop at all. So I'm going to comment that out. So. So I'm gonna go through this loop, right? And so we're only doing one loop for this one, for this particular case. We're gonna go through, and I'm going to say if array, the first array 1 at I equals, we're back here, counter, equals array 2 at I. Then what we want to do is increase our counter by 1. Counter plus plus. Oh. Count. What? Ah, that's why. Equals 0. So we increase our counter by 1. So that's if the values are equal at the same place, at the same index. So they're both, so index 1 or index 0, they are not equal. Index 1, they are equal. Increase counter by 1. Index 2, they're not equal. Index 3, they're not equal. We exit the loop. Counter is 1. Now, if you wanted to see, so for the next one, for H, they exist in anywhere in the array, then you would need a second for loop. So I'm going to take this and I'm going to move it here in this invisible if statement. So in this case, we're going to go through and so for the, basically it's going to test, it's going to take 3, it's going to look at 3, right, that's our outside loop, we're going to look at 3, and then for each index within array 2, we're going to check to see if 3 is equal to that. So is 3 equals 0, 6, no, 8, no, move on. Okay, so the second one, no, yes, and counter is increased by 1. No. Okay. Then we do 10. No. And then we do 2. No, yes, and counter is increased again. Now it's 2. And no. And then we exit, and the counter is 2 at the end. So if a value exists in one array but not the other array, so I'm going to get 10, right? So the value exists in one array but not the other. It's the same thing. You would just change this to it's literally that simple. So basically saying if they're not equal, increase counter. So as long as 3 is not no, actually. So we're going to set equal. So in this one, I would actually do if this does not equal, set flag to true, and then at the end of this for loop, I would say if flag counter plus plus. So basically what this does is, what am I getting at? Oh, that's fine. I hope they use the correct. So it's going to go through, and if the flag does not equal, if these two aren't. No, that won't work either. So this one does get a little more thinking than I thought. So this one's not that simple. So it does not exist in one. There. So what we're going to do is actually I'll do it like that actually. So I would go through, and if they're equal, we set the flag to true. No, that's not gonna work either. No, that'll work. Yeah. So basically, if they're equal, it sets the flag to true. And if none of them are equal, it will never be set to true. Therefore, not flag will become. Yeah. So if it's false, basically, if it's still false at the end of it, therefore we set the counter to. That's when we increase counter. That will work. Yes, okay. And that's 17. Number 18, how do you make a copy of an array? That's very simple. Let's say, get rid of that if statement. There's very little that has to change here. I'm going to get rid of these. I don't need either of those. And I don't need you anymore. Great. Array 3, and we're going to say equal to new integer array, and the size of the array, since we want them to be the same size, I'm going to be using array. I'm going to need one for loop here. Array 1, right? So array 1 length. So the length of array 1 is what we want the length for the array 3 to be. So they have equal lengths, right? Alright, and so the way we do this is relatively simple. So we're going to say array 3 at I equals array 1 at I. And that's it. That's all you gotta do. It's that simple. So this takes the value at array 1, or the value at this index for array 1. It says the same index of array 3. And that's how you make a copy. Let's see. I'm pretty close to being done here. When you want to loop over arrays, what kind of loop do you choose? So the looping over arrays is whether you're choosing for or for each loop. So if you need to know where you're at in your array, it's important to know if you're starting, what index you're at, if you will. If that's important to you, you're going to want a for loop. If you're changing the value. So I mean, if you change, for instance, you're changing the values. You're setting the values. You're changing the values in any way, shape, or form. Then you're going to use a for loop. If you simply need to read the values, if you want to take that value and look at it, or take that value and add it to another value, and add it to something else to put it to somewhere else, right? So like you're summing, you're making a summation of all the values in an array. Then that's where you would do a for each loop, and then that's the difference. The rest, when how you know which one to use. Can you find the value? Right, values, maximum, minimum. I think we've gone over sum. Average is the same thing. It's just you add them all together, and then you do a sum, and then you divide by the length, and that's or the dot length thing, and that's how you get the average. Maximum and minimum are the same process, but a little different. Copy. So if you want to know what the maximum or the minimum is, right? So we'll do for array 1. So if you want to find the maximum of array 1, all you have to do is say if, what we're going to do is create an integer called max, and we're going to set it equal to, excuse me, array 1 at 0. And then instead of starting at 0, we're actually going to start at 1. And say if max is less than array 1 at I, then you want to set max equal to array 1 at I. So basically, give us a space here. We set our maximum to the very first value in our array. And then we're going to go one by one, testing to see if the maximum is less than, strictly less than, the next one, right? The next variable. So that's why I started at 1 here, because it's kind of pointless to test to see if it's strictly greater than itself. So we'll start at 1. So basically it becomes max starts out at 3. Then we test to see is 3 greater than, or excuse me, is 8 greater than 3? It is. So now max is set to 8. Then we go through it, iterate it again. Now it's I is 0 is 2. Excuse me. I is 2. So is 10, which is that's our value at 2. Is 10 greater than 8? Yes, it is. Max is set to equal to 8. Then we continue forward. Is our array at 2 greater than 10? No, it is not. We exit. So now our max is 10, which is the maximum for this. And the minimum is the same way. There is an easier way to do that, but I didn't feel like doing it. And all it changes is minimum greater, strictly greater than that. And yeah, that's okay. I'm just change to that. And that's the minimum value. And then some I've gone over the sum before. You just going to iterate over all of them. We have this sum variable that holds it. I think we did that before up there somewhere. If you just you create some variable, say equal to 0, and for each iteration you add the array name dot I, you do a sum plus equals array name dot I. That's that line of code, and that'll give you the sum. And to find the average at the end of it, you just take that summation variable and you divide it by the array name dot length, and that will get you your average. average. Random class. Alright, so moving on to random classes. Nearly done here. Okay, random class. What is random class? I.e., what is it used for? So the random class is, much like it sounds, it's used for creating random objects. Or rather, objects that create random values or things in that nature. So the one that we use is the random. So we create this random object. I'm going to call it rando equal to the keyword new and random. And we haven't gotten to classes, so you don't really know what this line actually is doing. You will learn, however, that this is what's called a constructor, and it constructs a new random object called rand. And so we're gonna do we'll do 22 through 24 together. Okay, so we have our integer array called rando array. Equals new integer array of, let's say, 10 elements. Actually, I'm just going to call it, okay, there we go. Okay, so for I equals 0, while I is strictly less than array.length I plus plus. While we're inside here, we're going to use that random object. So array at I equals random dot next, and inside the parentheses is where we're going to kind of do this. That's where 22 and 23 come into play. You could say 1 and to 1,000. Now, when you say 1,000, it does not include 1,000. Actually, we could get 1 to 1,000, or you can just simply say 1,000, and it will actually starts at 0. So it goes from, if you want to start, for instance, you can start including 0, and to wherever you want to start. For instance, for this instance, it's 1,000, right? Excuse me, it's 1,000. But we don't want to include 1,000 in that range, so we're going to say this is actually going from 0 to 999. If you wanted to do the next one, random numbers from 200 to 100 to 200. So 100 is our lowest value, our maximum value, which is excluded, meaning it's not included in our numbers. 200. It's simple. It's pretty straightforward, relatively straightforward. And this would actually fill the array, and we'll display it at the same time as we're filling it. AR console right line array at I. So, a bunch of random numbers. Choosing random alphabets. So, if you remember, our characters and our alphabet numbers, they kind of coincide with each other. They direct relationship. So we can do the same thing. We can make this a character array. Now this is out of the range of the characters. And so I don't remember off the top of my head. I'm going to, for the time being, because I don't remember. Oh shoot. Like I said, I forget a lot of these times. So the ones you really want to learn and remember kind of help you out. I want to say a lowercase a is 96. But let me find out for certain. So I'm going to say int a equals the literal character a. And I'm going to console.writeLine a. 97. Okay, it's 97, not 96. So it's 97. So that means we need to start at 97, right? 97. And where we need to stop? Lowercase e. Control Shift. I can't be right at all. Oh, no, yeah, that might be right. So 122. So we want to go up to 100. So we're going to put 23 because we're not including that last number, if you will. And okay. So I will comment this out and uncomment this. Okay. Where is that? Oh. So, not sure if you forgot, but in order to go from an integer to a character, we need a casting operator because it's not going to implicitly do that for us. So we cast our number into a character. There you have it. F, X, R, N, Z, Y, R, H, L, N, K. And for uppercase, you just do the same thing, except you're going to use the corresponding numbers for the uppercase values. And that is everything I'm going to cover today. If you have any other questions, please send me an email, comment on this video. Yes, please contact me, like I said, on my email or come on the video. I will try to respond to everyone's questions in as timely as manner as I possibly can. But like I said, please comment, please send me an email. I will try, and I will do my best to answer it in as timely manner as possibly can. If you have, that's about all I got. All right. So good luck on your exam. I hope you all do excellent. I'm sure you will. I have good faith in all of you. You should have faith in yourselves. Remember to be careful. I'm going now. I know she's kind of laid out what she told me a little basic about what she's doing. Make sure you double check your syntax. You have it available for you for this test. Use Visual Studios. Use it to your availability on this test. Write in Visual Studios, test your code, make sure the syntax is correct, and then put it down in the exam. It's there available. Yeah, I know she says open notes. Use your notes. Use Visual Studios. And well, good luck. Because the reason I said that is because she said that she's going to mark a 0 for anything that is syntactically incorrect. So be aware of that. If you forget a semicolon, you're going to get a 0. Forget a semicolon.